Okay, so we're up to the fifth one, sixth one actually, F. We're up to exam 2 review F. Here we go. Heading Math 108, Spring 21, exam 2 review, and this is F. So that makes it the sixth one, I believe. All right, we're up to number 16, and it takes a while to get the information out on this. All right, so 8 balls are numbered 1 to 8. Numbered 1 through 8. Okay, and then the game, so to speak, is to pick one ball. And here's how the game works. You win $1. You win $1 if 1 is selected, right? If, in other words, the ball that has number 1 in it. If 1, the ball that has number 1 on it, if 1 is selected, right? So you pick the ball out of a pile, and if you look at it, it says number 1, so you win $1. $2 if 2 is selected. Okay, let me move this, put it over here. You'll see why in a second. $2 if 2 is selected, okay? All right, you'll see in a second why I'm doing that, because it'll make my life easier. That's good. That's the simple answer. I'll put $5 over here if 3 is selected. Then $6 right over here if 4 is selected. Then $8 over here if 5 is selected. $10 if 6 is selected. And now here comes a new twist to this plot. This is a plot twist here. You lose, whoever's playing this game you lose $13 if 7 or 8, right? So those are bad numbers for this game, or 8 is selected. Or 8 is selected. Okay, now, so what is the expectation of this game? That is problem 16A. What is the expectation? So let me show you the formula. Let me move this up. I wanted to try to get clarity here. I need you to see the problem, but I want more space. So expectation, here's the formula. You take the reward for, let's say they pick 1. What are the chances? What are the chances of picking 1? 1 out of 8. What are the chances of picking 2? 1 out of 8. What are the chances of picking 4? 1 out of 8. 7. 1 out of 8. They're all 1 out of 8. So if you pick 1, you get a reward of $1. I'm not writing the dollar sign. It's too much trouble. You get $1, and there's a 1/8 chance of that happening. So you multiply the reward times the probability. That's how you deal with expectation. What's your reward for picking a 2? $2, and there's a 1 out of 8 chance that happening. The reward for 3, $5. You can look it up. All the information is here. $5, 1 out of 8 chance that happens. How about if you pick a 6? If you pick a 4, you get $6. If you pick a 4, 1 out of 8 chance that happening. If you pick a 5, it's $8, 1 out of 8 chance that happening. If you pick a 6, $10, 1 out of 8 chance that happening. Now here's the twist. Watch it. Be careful. Minus 13 if you pick a 7, 1 out of chance that happening. And then minus 13 again, 1 out of chance that happening if you pick an 8. 1 out of minus 13 times 1/8. Now let's tally all this up. Keep the eighths. Don't reduce anything right now. Don't reduce anything. It just makes your life harder. Keep it with eighths for the moment. Let them all be talking in eighths. So this is equal to 1 times 1/8 is 1/8. 2 times 1/8 is 2/8. 5 times 1/8 is 5/8. 6 times 1/8 is 6/8. 8 times 1/8, don't write 1, just write it in eighths, 8 over 8. 10 times 1/8 is 10/8. Minus 13 times 1/8 is minus 13/8, and minus 13 times 1/8 is minus 13/8. 1 and 2 is 3, 3 and 5 is 8, 8 and 6 is 14, 14 and 8 is 22, 22 and 10 is 32, minus 26 is 6 over 8. Reduce that to 3 over 4, and what is this? What are we talking the whole time? Dollars, 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 dollars. This is 3/4 dollars. How much is that in decimal? 0.75 of a dollar. 3 divided by 4 is 0.75, 75 cents. It's $0.75. Okay, that is the question. That is the answer for problem number A. That's the expectation, etc. Now, there's a B. I need to get that B on here on the same page. I don't have much room, but I got to do what I can do here. There's going to be 3 choices with buttons to pick. One of them is, with this game, do you break even? That's one choice. Another choice, do you gain? And if you do, how many dollars do you gain? How many dollars do you gain? Per selection. We're talking about per selection. And finally, the last choice is, do you lose? And if you lose, how many dollars do you lose per selection? You choose gain, because this is a positive number that we got at the end of the game. 3/4 at the end of the day. 3/4 is 0.75. That's all positive. That means you're gaining by you doing this game. And if that's the case, you pick gain. How much do you gain? You gain 75 cents every time you play this game. It doesn't mean in reality you get 75 cents. Let me explain that a little bit better. We talked about it probably beforehand. And that is that if you could play it once and you could lose $13. You could play it once. You get a 7. You have to pay out $13 and you leave. You lost negative 13. But if you play this over and over again, over time, the expectation is that you're actually making 75 cents every time you play. That is what expectation is. It's a long-term expectation. Okay, 16A and B is over. Let's go to 17. There should be more time on this for us here. New, fresh page. Okay, now, number 17. All right, 6 sodas. 6 sodas. 8 water bottles. Choose 7. Choose 7 randomly, of course. What's the probability? Here's the question. What's the probability of choosing? Well, I don't need the parentheses. I'm sorry. What's the probability of choosing? And let me write a question mark here, because this is the question. What's the probability of choosing 3 sodas, and 4 water bottles? Okay, we've had this before. Here we go. What's the denominator of the entire sample space? Well, there's 14 to select from. Oh, first of all, before we start, sorry. Permutation or combination? Is it going to? Do we care what order these sodas come in? What order these waters come in? These water bottles come in? No, order's not important. We're talking about combination. Let's go to the sample space. How many in all are we choosing from? You're choosing from 14 bottles. 6 and 8 is 14. How many are? That's our N. How many are R? How many are we choosing? 7. There is the denominator right there. Combination 14, 7. Now, what are we interested in picking? The probability of choosing 3 sodas. Let's talk about the sodas first. We don't care about the order. There are 6 sodas, and we're picking 3 of them. What about the water bottles? Well, there are 8 water bottles, and we are picking 4 of them, right? We're interested in picking 4 of them. So there it is. Those are the numbers that we got to deal with. Okay, you might have to do some of these numbers yourselves, but let's do some of it together. The C63 turns into 6 factorial over 3 factorial, and 6 minus 3 is another 3 factorial. And then over here, the times up here is going to be 8 factorial. 8 minus 4, 4 factorial is r factorial, and 8 minus 4 is another 4 factorial. And all of that over the following, over 14 factorial. This is the denominator. 14 factorial and then 7 factorial. Then 14 minus 7 is another 7 factorial. That's what we've got to figure out. So if you go to scrap paper, and you try to figure out what is 6 factorial, 6 factorial, this one, we're going to try that, is going to be 6 factorial over 3, right? Pick the largest one, or one of the two. They're a tie. So it's 6 times 5 times 4. You get to 3. Stop. There's a 3 that's still hanging out here. 3 times 2. 3 times 2 is 6. Cancels. 5 times 4 is equal to 20. So the top left is actually just a plain 20. Okay, not so hard. More scrap paper. What about this one? To do take the 8, and it's a tie, so you take either of the 4s. What do you got? This is all scrap paper. I got scrap paper space here. Hold on. Right, I need the scrap paper space. So I've got 8 times 7 times 6 times 5. You get to 4. Stop. And then underneath it, you do 4 factorial, which is 4 times 3 times 2. I don't need the 1. What does that get for me? 4 times 2 is 8, and this crosses out. The 3 goes into the 6 2 times. What do I have? 7 times 2 is 14. 14 times 5 is 70. So I've got this turns into a 20. This turns into a 70. Okay, now the harder one. This is the bad one. 14 factorial over 7. Choose one of them. It's a tie. Choose one of them. So you got 14 times 13 times 12 times 11 times 10 times 9 times 8. You get to 7. Stop. 7 factorial. 7 times 6 times 5 times 4 times 3 times 2. I don't need the 1. Okay, 7 times 2 is 14. They cross each other out. What else? What else do we have over here? Let's try... Oh, 4 times 3. 4 times 3 is 12. That'll go. Okay, what's left? 6 will go into... 3 goes into 6 twice. 3 goes into 9 3 times. Okay. What else do we have? The 5 and the 2 are 10, so that we can cross that out. 5 times 2 is 10. This can cross out. And what do we have left standing over here? 13 times, this is going to be 13 times 11. How much is 13 times 11? It's 143. 143. And how much is 3 times 8? It's 24. Okay, now that's already manageable. You can take care of that. I'll do it pretty quickly with my way, but you can do it. You can take your calculator and do that manageably. 4 goes into 24 6 times. 4 goes into 25 times. And now you got a pretty manageable situation that you have like 350 on top there, and etc. So that should be pretty manageable. Okay, so we'll stop here. Hopefully I did that right, but you have a calculator.